Co-op.
Scientists,
Co-op.
Lucy and the Sky with Asteroids. We're gonna learn asteroids.
Hello and welcome everyone to Scientists in Action, Lucy in the Sky with Asteroids. I'm your host, Kate, from the Denver Museum of Nature and Science, where we're filming behind the scenes in our green screen studios. I am not, in fact, in space. That would be pretty amazing. I should probably have different equipment and gear for that, though. A couple things I want to talk about before I introduce our amazing scientist. First and foremost, if you're going to be our on-camera school, and I see Telluride Middle School has already joined us, amazing. We saw you, we could hear you. We'll have you stay muted and off camera until we're ready for you in our Q&A in about 15 to 20 minutes. If you are not going to be on camera and you have questions, I love it. We have an open chat. So students, teachers, however you have those computers set up, you can be adding those questions to the chat throughout the program, and we'll make sure our scientist gets them. On that note, I would love to introduce you to Vicki Hamilton. She has some really amazing facts to share with us, some really cool graphics. Vicki, go ahead. If you want to tell us a little bit about yourself and the Lucy mission, I cannot wait to learn from you.
Thanks. I'm Vicki Hamilton. I'm a geologist at the Southwest Research Institute in Boulder, Colorado. I'm actually a planetary geologist. I don't just study rocks on Earth. I study them on asteroids, on Mars, and anywhere that NASA wants to send a spacecraft. So that's what I do. And what I would like to talk to you about today is a specific mission called the Lucy mission. And the Lucy mission is going to visit a series of asteroids. And what I want to talk about first is kind of how we got the name of this mission. You see that diamond on the right there, that's our mission patch. And so it has the name of the mission, Lucy, and that refers to the thing on the very left-hand side of that patch, which is a fossil. It's a bunch of bones. And when you expand that up, you see the bones on the far left side of the screen. That is the Lucy fossil, which was found in Ethiopia in the 1970s. And it was a really important fossil for anthropologists to find because it told us a lot about the origin of the human species. Well, like these bones tell us about human history, asteroids can tell us about solar system history. So the asteroids are shown on that mission patch on the right side. And then in the middle, you see those round discs. That's our spacecraft, Lucy. And so we're going to talk about what we want to do with this spacecraft, where we're going to do it, and how we're going to do it. So the target asteroids that we're going to are called Trojan asteroids. So if you look at the animation on the left-hand side, you're looking top down onto our solar system. So the sun is in the middle, and then you can see Mercury and Venus, Earth, and Mars rotating around the sun. And then there's a big cloud of sort of brown dots. That's the main belt of asteroids. When you go to the next ring out, you'll see that it's labeled Jupiter. So that's the planet Jupiter. And then in its orbit, you can see two blue clouds of dots. Those are the Trojan asteroids. So they share Jupiter's orbit. There's about 1 million of them that are larger than a kilometer in size. And the largest one is about 225 kilometers in size. And so if you're familiar with Colorado geography, that's about the distance between Boulder and Pueblo. So what is it that we know about Trojan asteroids? I mean, we know they're out there. We've never been to them with a spacecraft and never seen them, but we do know a few things about them. And one of those things is that they're very, very diverse. So they're different in terms of their colors. Some of them are gray, some of them are pinkish or even red. And then some are really, really dark. They're darker than charcoal. So that's really, really dark. Some of them are weird shapes. There are some that are potato shaped or sort of oblong. And then others even have satellites. And satellites is just a fancy word for moons. In addition to that, we know a little bit, we think, about how dense they are. So rocks are very dense, they're very heavy, but these asteroids have density that is, generally speaking, less than rocks. And in some cases, the density is even less than water ice. So if you think of ice cubes in water, the ice cubes float because they're less dense than the water they're sitting in. So we think a lot of these Trojan asteroids are less dense than most asteroids. Now, I talked a little bit about how diverse these asteroids are in terms of their color or their shape or their, brightness and darkness. In order to really understand them, we can't just go to one. And so a friend of mine created this picture to help people understand why we need to go to more than one. So imagine you're blindfolded and your friend hands you a basket and says, "This is a fruit basket. Tell me what fruit is in it." And you reach in and you grab something out and you have a banana. So you say, "Oh, it's a basket of bananas." But the problem is that you only tried one. If you had gone back to that basket and looked at all the other things, you would have realized that there was much more than just that banana there. And so the same thing is true of our asteroids. Now, I'm going to talk about how we actually get all the way out to Jupiter's orbit and encounter these asteroids. So we're looking at the solar system again here, top down, with the sun in the middle and Earth's orbit in blue around that. And I'm going to start a animation here in a second that will show you in red what happens with our spacecraft, where it goes after we launch it off the Earth. Now, the thing that happens here is that it goes out, it comes back, and then it starts to go further out, and it goes out to the main belt of asteroids, then it comes back in again, and then it swings all the way out to get out to Jupiter's orbit. And that's where it encounters the first set of our Trojan asteroids. After it goes through that group of asteroids, it swings back into the inner solar system and then flings back out to Jupiter's orbit again to catch the last couple of asteroids that are following Jupiter in its orbit. So you can see here that we encounter, 2, 4, 6 asteroids on our first trip out, and then 2 more at the end.
Can I ask a question about this flight plan?
Sure.
Why is Lucy making so many loops? Wouldn't it just be faster to go directly to the Trojan asteroids?
It would, but it's like making a long distance trip in your car. You need to have enough gas to get to where you're going. And unfortunately, it takes so much fuel for us to go directly to Jupiter that we just can't carry that much. So what we do instead is we take advantage of gravity. And by swinging past the Earth, we get sort of a slingshot effect. Like if you have one of those toys that you use to hold a tennis ball and fling it for a dog, it gives it a lot more power and a lot more speed when you do it that way. So that's how we get out there without having to carry all that fuel.
Very cool. And I see Earth gravity assist on the bottom of the slide. So that makes sense. Very cool.
Yep. Yep. Okay, so here are some images of what we think these Trojans might look like based on the amount of data that we have so far. But these are not pictures of the asteroids. We don't have those. So we're making an interpretation of what we think they'll look like. But again, these are very diverse. They are all different sizes. You can see here that some are much, much larger than others. You can see that a few of them have little moons next to them or that are orbiting around them. Some are gray, some are red. And then the 2 at the bottom, Patroclus and Menetius, are actually what we call a binary or a pair of asteroids that actually orbit each other. So we're going to sample all of this diversity with our mission. We're going to look at maybe 1 of the or 2 of these examples to talk about different ways we think these asteroids might form. So Euripides here, it has a little moon called Kata. It's a gray asteroid. And in August of 2027, we're going to go fly past it and see what it really looks like. And then we'll have a real picture to show you. But we think it formed from a big collision between big asteroids early in solar system history. And that's what the picture on the right is showing you, is in terms of an artist's rendition of what that might look like. But what I'll show you next is a computer simulation of what happens after a collision like that. So in the middle of that picture is Euripides as it is starting to form after that collision. It has gravity, so it attracts in new pieces from that collision, and it grows until it gets to be the current size it is today. And then its moon, Kata, gets trapped into an orbit around it. If we look at another pair of asteroids that we're going to look at, this is that Patroclus and Menecius pair. And you can see from the graphic here, the animation, that they're orbiting each other. It's not like one is a moon and the other is the main body. They're just orbiting around each other. And we don't even totally understand how this happens. So we want to go see this set of asteroids to try to learn a little bit more about them. But I said before that none of these are actual pictures of asteroids. One of the best images we have so far of this pair of asteroids is down in that little green box at the lower right corner. And right there, it just kind of looks like a fuzzy dumbbell. And that's as much as we know, but we can take lots of pictures like that. And that's how we see that they actually are orbiting each other, because we watch their positions change. And that image was taken with the Hubble Space Telescope, one of our very powerful telescopes that's out in space. So I've told you a bit about where we're going to go with Lucy. Let's talk about the spacecraft, how we're going to actually do all this science. So the Lucy spacecraft actually carries a diamond on it, which is kind of cool. It weighs about 3,300 pounds, and that's about the weight of some small cars or as much as a rhinoceros. Half of that weight is all the fuel, the gas that we have to carry with us. Now, if you were to take apart all the wiring inside our spacecraft and lay it out in a line, it would extend over 2 miles. So that's an awful lot of wire. And because, as you saw in the animation, Lucy goes out to Jupiter and then it comes back towards the Earth and then it goes back out again, it goes really close to the sun and then it goes far away from the sun. And that means that the spacecraft has to be designed to withstand very cold temperatures like minus 250 degrees, all the way to very warm temperatures like 300 degrees. Now, in the middle, that spacecraft image, those big circular areas, those are our solar panels. That's how we get power. So we use the sun to power our spacecraft and our instruments. And because we're going to be so far away, we need really big solar panels. So the spacecraft is 52 feet across, and that's about as tall as a 4-story building. Now, if we look closer at the Lucy spacecraft, on the left, you'll see a little box area there called the instrument platform. That's where all of our science instruments sit. And we have 5 different instruments that tell us about the geology of the asteroids, about what they're made out of, about what their interiors are like, even though we can't see them. And then we can also use these instruments to tell us whether these asteroids have satellites, or which are moons, or rings that maybe we didn't know about. So in addition to the instruments, we also use our antenna on the spacecraft to do science in these fields, as well as communicate with us, send our data back, and generally help us communicate with the spacecraft. This is an actual picture of that instrument platform. And this isn't the whole spacecraft, just the part where the instruments sit. And you can see the 2 people there for scale. And the instruments have the little blue lines showing you where the different instruments on that graphic on the right, where they're actually located on that spacecraft.
Could I ask a question about this picture? These engineers, why are they wearing these outfits to work on this piece of equipment?
Yeah, that's a really good observation. So one of the things that we need to be worried about when we build a spacecraft is keeping it really clean. So one of the things you'll see is where those little blue dots are over there on the left, showing you where the instruments are. The instruments actually have covers on them. Some of them are red, some of them are our silver bags, but then the people also have cover on them too. And all of that is to prevent hair or skin or dog fur that might be on the people from getting on the spacecraft and getting on our camera lenses. Because once the spacecraft is in space, we can't clean it up again. So we have to keep it clean while it's here on Earth.
Very cool. Yeah, that makes a lot of sense. Very smart.
Okay, so let me tell you a little bit about how the Lucy spacecraft works. This is an animation that I'll start in just a minute, but I want to show you what you're looking at. So the spacecraft is in the center of the image, and down at the lower right, you see a bunch of text in yellow. That's going to start changing in a minute, and that's going to tell you things like the distance to the asteroid. And up at the top right, you see Monoecious. There's a little dotted line there. You can't actually see Monoecious yet because it's so far away, but when we start this animation, it'll start to get closer. Now, what I'm showing you is an animation at 200 times the speed this will actually happen in real life. And as you see these little flashes and these little triangles start to stretch out from the spacecraft like that, you'll see that they're in different colors. And those colors tell you which instrument is collecting data at that point in time. And it connects to the text in the upper left corner. Those are the names of the instruments. So as Monoecious and Patroclus get closer to our spacecraft, or really as we get closer to them, you'll see that we start collecting more and more data. So this is one of our science instruments called Ralph Lisa that's collecting data right now. And so what you'll start to see is that as we get closer and closer to these asteroids, the spacecraft has to start to rotate to keep them in our view. That's sort of like if you're sitting in the car in a passenger seat and you see something up ahead, and then you turn your head to look at it when it's next to you, and even as you go, it goes behind you. And that's what our spacecraft does. It rotates so that it can keep looking at the asteroids and collecting science data until we get so far away that we can't see them anymore.
Could I throw you a question from our friends at Telluride Middle School? They're
Please.
asking how large or like how heavy are these asteroids? What kind of elements are they made out of?
We don't know how heavy they are. We know their sizes roughly. Let me back up because I can take you back to a picture with that. So this gives you a sense. This white bar down here is 50 kilometers in size. So some of them are like Polymele up here, only about 25 kilometers in size. And then you've got Patroclus and Monoecious, which are closer to 125 or 150 kilometers. And then was there a second part to that question?
It was essentially what kind of elements are they?
Right. So what kind of elements? So we think that they're made mostly of the same kinds of elements that rocks on Earth are made out of. But sometimes we think, based on looking at meteorites, which are pieces of asteroid that fall on the Earth, that sometimes the minerals are a little bit different in terms of which elements they've put together. But that's part of the point of this mission, is to try to figure out exactly what they're made out of.
Cool. So that's part of what you're looking for on these asteroids.
Yeah.
Nice. Cool. All right. There are more questions. We can hang on to them for now. I'll let you continue.
Okay. So anytime you build something like this, one of your questions is, well, we have a great plan. I've shown you what we want to do, our plans for how to do it, but will it really work? And one of the things that happens sometimes is that while we test most of our instruments and most of our spacecraft here on Earth, there are certain things that sometimes we can't test until we actually are in space with the spacecraft. And one of those things is part of our navigation system, or how we get to where we're going. And so we had an opportunity late last year to visit an asteroid in the main belt called Dinkinesh. So again, this is our picture of the solar system looking from the top down with the sun in the middle. And then you can see where Venus and Earth and Mars are. And then over on the left, you see a blue plus sign, and it says Dinkinesh. Well, it turned out we had no plan to go see Dinkinesh, But it turned out that we could go there without going too far off of our path to getting to the Trojan asteroids. So we pulled over a little bit, took a slightly different route, and we flew past this asteroid, Dinkinesh, to test one of our navigation systems. And it turned out to be a really useful exercise. So now here are real pictures of a real asteroid. This is the asteroid Dinkinesh. And you'll see off to the left that there's actually another object nearby, and it's going to swing past. And this is what it looked like in the rear view mirror. And you can see that other object, and it too looks kind of like a little barbell. So we learned that Dinkinesh has a moon, and then we learned that that moon is made up of two little tiny asteroids. So not only were we able to test our systems, and we used all of our science instruments and verified that everything worked, we did some amazing science. We didn't know that there would be a moon, and we didn't know that it would be an object like this. So we're going to have more images like this when we get to our Trojan targets. Now, here's one of those pictures from that last sequence. And so this is Dinkinesh, and then that little dumbbell that is orbiting around it, that is its moon, is called Salam. And if we look at the size of Dinkinesh and Salam compared to some objects here on Earth, like a skyscraper or the Roman Colosseum or the Eiffel Tower, you can get a sense of how big they are. So with that, I will leave it open to you to ask whatever questions you have, and I will do my best to answer them.
Amazing. Very cool. Well, at this point, I know our friends at Telluride Middle School have, it sounds like, a fire drill planned relatively soon. But Nancy Swick's crew, if you want to join us on camera briefly, we'd love to maybe steal a question or two from you before you have to run out for your fire drill. Unless they've already gone out for that fire drill.
Oh my God, will we be on live stream on YouTube?
Let's go.
How many views
Okay,
will
let's
I
be
get?
famous.
0.
Wait,
I got breath.
which space station are you using to do this again?
Like to launch these things from?
Yes.
Sorry. So we launched our spacecraft from Florida, and then the spacecraft is the Lucy spacecraft that you see in that that I was showing you in those previous images. Did that answer your question?
Which space station? Like,
So we're not using a space station. So there's the International Space Station that has the astronauts in it. That's orbiting the Earth. Our spacecraft launched from the Earth, and it's gone way far away out to the asteroid belt and on towards Jupiter.
Very cool. I bet that launch from Florida would have been really neat to see.
Yeah.
What's another question from our friends in the classroom? Hi.
What's the speed that Lucy travels at?
We've gotten this question a lot. Lucy travels really, really fast, about 30,000 miles per hour. It's going at Jupiter's orbital speed around the sun. So it has to travel really, really fast.
That's really fast. A lot faster than cars or flights or any of the things that we take here on Earth. So great question. What's another question from the classroom?
I was wondering, where is Lucy right now?
Right now, Lucy is crossing the main belt of asteroids that are between Mars and Jupiter.
Very cool. Yeah, if you've ever looked at those pictures from solar systems, you can see there's kind of a lot of asteroids between the rocky planets and the gas planets.
Yeah.
So very cool. Lucy's way out there. What's another question from the classroom?
Wait, I forgot my question. Oh yeah. Is there any other asteroids that you guys explored other than that one? Or like is there any pictures that are more clearer than the other one that you showed us?
So not yet. We will get those pictures over the next 5 to 10 years. And so as you guys grow up and get older, you'll get to see those asteroid pictures get clearer and clearer as we visit more of these Trojan asteroids.
Very cool question. Yeah, this mission is long enough that some of our friends in the audience could even be working on this mission someday.
Yeah.
Cool. If you do, let us know. I want to know that. All right. Another question from Telluride Middle School.
How long did it take to build Lucy?
So we started building the spacecraft in 2017, and it didn't launch until 2021. So, 4 or 5 years. And that's only after we learned that we would be allowed to build it. We had to ask NASA for the money to do this. And so if you count that amount of time, it's closer to 10 years.
Wow. So an entire mission like this could take upward of a quarter of a century is what you're saying.
Yeah, absolutely.
You
There's a
have to
lot that goes into making it work.
You have to be really patient as a space scientist, it looks like.
Yeah, it goes fast though.
Oh, looks like that maybe they're taking their fire drill. Bye, we'll see you next time. Good thing we have some amazing questions also in the chat. I'm gonna go ahead and jump into these as well. So thank you for giving us all these amazing questions. All right, so we have one from, this looks like Sanborn Elementary School, and it is, if the Trojan asteroids were formed during the creation of the planets, and if one of them was formed during the creation of Earth, could they have signs of life on them?
Ooh, that's a really intriguing question. We think that the answer, though, is probably no. And the reason is that Earth was formed out of primarily asteroids and comets, but life didn't evolve on Earth until a lot longer later, after the planet formed. The asteroids that are still around today are the asteroids that never got swept up into a planet. So they don't have any atmosphere, they don't have any water, there's no plants. So it's pretty unlikely that there's any life on them.
Very cool. Here's another follow-up question from Sanborn Elementary School again, and it is, what will happen if Lucy loses her power? Would her size affect how long she could last in space?
Oh, okay. So if Lucy were to lose her power, we wouldn't be able to talk to her anymore. But she would probably continue to stay in orbit around the sun for ever, effectively. But we would never be able to communicate with her again.
Oh, sad.
It is. Hopefully that won't happen.
I know. So here's kind of a related question, and this one, it looks like, is from 279 online. They want to know, will Lucy come back? So I guess regardless if not she loses her power, will she come back to Earth? What's the future for Lucy look like after she's completed her job?
After Lucy has finished getting all this science data for us, she'll remain again in orbit around the sun. Right now, we don't have any plans to send her anywhere else. We can't bring her back to Earth. She's not equipped to come through our atmosphere and come back. If she tried, she would probably burn up. That's not nice to think about. So she'll probably stay in orbit around the sun, but who knows, if we still have some fuel left at the end of our mission and we see another asteroid that we could get to, maybe we'll add some asteroids to our list.
Brave Lucy with her one-way ticket. Oh.
Yeah.
Here's a question from Tarver Elementary. Why do the Trojan asteroids follow Jupiter?
That is a really, really insightful question. And so it turns out that when the solar system was forming, things were moving around a lot. All these asteroids are condensing out of this ball of gas and dust, and they're kind of all over the place. They're going back and forth, in and out towards the sun. And it turns out that the Trojans just happened to get captured in gravity wells, is what we call them, but they're special points in Jupiter's orbital path where it's convenient for them to get kind of stuck there. And so that is what happened. Most of the asteroids we know about are in the main belt. So that makes the Trojans special. They're the ones that got stuck in Jupiter's orbit.
Very cool. That was a great question. From Lake Benton Elementary School, we would like to know, how do you control where Lucy travels? Can you?
Yes, we absolutely can control where Lucy goes. And we have like, if you, here, let me do one quick screen share again. You can see that this is the spacecraft. You see there's a rocket or an engine on the bottom of it that's firing. We use that to push Lucy in a particular direction. And so there isn't just one rocket engine, there's a bunch, and we can use them to control where Lucy points and so where she goes.
Very cool. Here is another question from, it looks like Tarver Elementary, and they want to know, were you present at the building of Lucy?
I was, in fact, I am a team member that helped build one of the scientific instruments, what we call a thermal emission spectrometer. And so, yeah, I got to be part of the process of building that instrument. So it's nice to know that it's out in space doing its job.
Yeah, your virtual fingerprints, because I know we had to protect it from real fingerprints, but
Right.
they're on there. A follow-up question to Tarver's question is, was it built here at the Denver Museum of Nature and Science? I can answer that one. It was not. That would be so cool. So maybe someday we could have our own museum satellite or probe or just spaceship. Would love that. That would be awesome. Let's see. Here is another one. Is there anything besides asteroids that Lucy can and will investigate on her mission?
Not currently in our plan. We have a lot to do just to get to all of the asteroids that are in our plan, in our travel itinerary. And so right now we won't be going anywhere else, but who knows, maybe someday we'll find another asteroid that we didn't know was there and we'll want to go look at it.
Very cool. 279 online wants to know, could Lucy fall back to Earth?
No, Lucy is zipping around the sun in that sort of loopy path that I showed you. And so she'll stay that way, and we keep her going so that she doesn't actually fall back to the Earth.
Very cool. That's reassuring to know. Speaking of things running into Earth, though, we also have another question from 279 online, and they want to know, what is the closest asteroid to Earth? Are we at risk?
Well, there are asteroids that are close to us, very close to us all the time. Most of them are very, very small. Some of them actually impact the Earth, and we find those on the surface of the Earth as meteorites. That's what a meteorite is. It's a piece of an asteroid that's fallen to Earth. Most of those aren't dangerous, but every once in a while, there are really large ones that cross our path around the sun and could run into us. But that's really unlikely. The most dangerous asteroid we know about isn't very likely to hit the Earth, and if it did, it wouldn't happen for another 180 years.
That's lucky, at least for us, because I don't
That's
think
for
I'll be
us.
here for that long. This one is from Teach Northwest. And I think you might have mentioned this earlier, but if not, why the diamond? Why does Lucy have a diamond with her?
Lucy has a diamond. Again, we were talking about the fact that I helped build one of the instruments. Well, it turns out that inside that science instrument, we have a little window or a little lens. And because of what we need it to do, it's actually made out of diamond. It's a manufactured diamond. It's made in a lab, but it's still a diamond. And so Lucy has a diamond up in the sky.
Oh, Lucy's diamond in the sky. This one looks like it's from Spring Studio for Academic Excellence. And we want to know what would happen, or could some of those, it says teen, but it might be Trojan asteroids eventually colliding. Do those asteroids run into each other?
Occasionally, yes. Most of them are pretty far apart from each other at this point, but it's always possible that there are small collisions that occur, but they don't happen very often.
Very cool. That's reassuring. I think earlier you also mentioned just how far apart all these things are. These are massive objects and space itself is huge, which is reassuring. Another question in the chat, and I can't remember who asked this one, but how do we protect Lucy from things like asteroids? Is Lucy ever at risk of damage herself?
Yeah, that's a very good question. And it comes back to the fact that space is huge. You know, it's hard to conceive of just how far apart these things are. And even though in one of those animations, the main belt asteroids look like this dense swarm of particles, they're really, really just hugely far apart in space. So Lucy doesn't really have to worry too much about running into any of them, even as we go through the asteroid belt. And then we are very careful when we get to our Trojan asteroids to make sure that we don't run into them. So we control the spacecraft so that that doesn't happen.
Nice. And to that extent, is this the first Lucy, or did we have Lucy's before it that maybe didn't make it?
There were no Lucys before Lucy. This is the first mission that will go out to see these Trojan asteroids, but we have flown other missions to asteroids. There's a mission called OSIRIS-REx that went to an asteroid and brought a sample back. The Japanese have sent a spacecraft to an asteroid and brought a sample back, and maybe someday we'll get a sample back from a Trojan asteroid.
That would be awesome. There's a follow-up question. Another school, it looks like this is Tarver. They would like to know if Lucy's on the way to Jupiter, do we have plans to send any other rockets to Jupiter as well?
Not right now, but there are some other spacecraft that are there already. So one of them is called Juno, and it's been studying Jupiter for several years now.
Very cool. There's just so many things to explore in space. I hope so many of our audience members become space scientists themselves, whether or not it's for the geology or the engineering into that. There are quite a few questions left, but I know we also have a special treat in that we've got quite a few videos, correct, of rocket launches. Is that something that we could pull up? I think it's of Lucy actually taking off, if I'm not mistaken.
That would be great.
Let's see. It looks like we can go ahead and get one of these pulled up. Awesome.
So up at the top of that rocket is where Lucy is. It's in that cone. And you can see that mission patch there. And this is them getting ready, and there she goes.
How much fuel does it take something like this to happen?
Oh my gosh, I don't know how many gallons. It's got to be hundreds of thousands of gallons. It is a lot of fuel. It takes a lot to get off the surface of the Earth.
There's a lot of gravity, it's true.
Yeah.
So Lucy is traveling in this, you said, capsule, and then it breaks apart in space and out Lucy comes? Like, how does this work?
Yeah, I mean, it's a little bit like a little chicken coming out of its egg, right? So that cone up at the top of the rocket, once the rocket actually gets into space and it's outside our atmosphere, once that happens, that cone splits in two and it kind of peels back, and then Lucy goes on its merry way.
Awesome. Well, that was really cool. I've been wanting to see that all day. This was the first session that we got to play that for. So that was really cool. I don't know if there are any other animations we want to cue as well. I just was like, we got to show everyone this one. It's awesome. Some other questions I'm seeing from the chat. This one is from Sanborn. It says, we know that the asteroids are where they are because of the sun and Jupiter's gravitational pulls. But what would happen if Lucy got stuck in that pull? Could Lucy get stuck out there, or will Lucy always come back?
Fortunately, Lucy will always come back. She's traveling at a rate of speed that allows her to keep going and not get caught in that gravity well.
But if Lucy did, and this is from a different school, could you make potentially another Lucy? Would we make another one if something happened and Lucy crashed or just disappeared?
Well, that depends. There have been spacecraft missions, for example, to Mars that crashed, and NASA rebuilt them and sent the instruments again. If something like that were to happen to Lucy, we don't know. I mean, that's a what if kind of question, and we don't know what the answer is for sure, but certainly we would want to try to get that science some way. And so rebuilding it is one potential option for doing that.
I don't remember if you said this earlier, but someone in the chat is asking, what is the price tag associated with this mission? So if we had to rebuild Lucy, how much money are we talking about?
It's a lot of money to all of us. It's a lot more money than any of us have in our bank accounts, probably, but Elon Musk could pay for it very easily. It's about $500 million. And that's spread out over the whole lifetime of the project. So probably 20 years to spend that amount of money.
You have to be really budget savvy in order to make that work. So that's very cool. Think about all those projects that you probably do in math class, or maybe even science, as you're given an allotted amount and you have to try and come up with something. Looks like that skill is actually quite applicable someday in the future if you work for NASA or Southwest Research Institute and you are trying to send something actually into space. Kind of on that note, there was an earlier question of who all is involved with this. It's not just NASA, is it?
No, it's not just NASA. I am, people like me. I don't work for NASA. I work for a company that does space science as well as other things. But the people who built the spacecraft are at Lockheed Martin down in South Denver. There are people at other institutions that provide hardware that we put on our spacecraft or in our instruments. So there's all kinds of folks who help contribute to a mission like Lucy, and they're not all scientists. Some of them are engineers of different kinds. Some of them, we were just talking about money and budgets. Some of those people are accountants. Some of those people are writers. Some of those people are educators. They help us do things like what we're doing right now to help the public and kids and anybody who wants to know, understand what it is we're doing. So it's a lot of people.
Very cool. Kind of to tag on to that, this question is more geared towards you, but how did you become a planetary geologist? What if someone else watching this wants to do something like a Lucy mission someday? What were the steps you took to become this?
Yeah, so I was in college when I decided that I wanted to be a geologist, and I happened to take a class about the planets. And it got me really, really interested in this. And so I went and did an internship at a place called the Jet Propulsion Laboratory in California, where they fly a lot of NASA missions. And so I got to see firsthand what it was like to do this. And it just sounded like the best job in the world. So I continued going to school for a little while longer, and then I became a planetary geologist.
Very cool. I like that. It's interesting, your story. I think for anyone who's watched any of our previous programs, there's an essence to it where sometimes you have one idea of what you're going to do, maybe an interest. I don't know if you were interested in geology and rocks since childhood, but then at some point you kind of fall into something and your interest just kind of changed direction, much like Lucy maybe, and you kind of pursue it from there. So that's so cool. Very neat. All right, so we've got just a little bit more time, but there are a couple more questions I want to ask. One is, have the asteroids always been where they are today?
Oh, no, they have not. Actually, a lot of the asteroids were kind of zooming around the solar system as the solar system was forming, as the planets were forming. And so a lot of them used to be closer to the sun or used to be further from the sun than they are today. So they've moved around quite a bit.
Very cool. Here's an earlier question. Is there anything you would have liked to add to Lucy that didn't really happen this time around?
Our mission was designed to carry everything we felt we really needed. But if we'd had a little more space and had a little more money, there's a certain kind of instrument called a neutron spectrometer that measures things like hydrogen or water. And it would have been kind of fun to have one of those to maybe see if we saw any ice on these asteroids.
Very cool. Yeah, and I think someone asked earlier about life, and I don't know, if we found water on asteroids, that might be maybe one of those things we could think about. So that's cool. What is your favorite part of your job?
Ooh, my favorite part of my job. Well, because I'm a scientist, my favorite part of my job is getting to analyze the data that we collect. So, when we saw Dinkinesh last fall, it was really, really fun to get to finally work with those data and learn something new about an object that we had never seen before. I also work on other missions. And so I have worked on pieces of asteroids that have been brought back by other spacecraft. And that is incredibly fun.
Very cool. There's so much to explore. These have been so many amazing questions. Is there anything you want to leave our students with today as far as final words or words of inspiration?
Yeah, just to, keep your options open. And there's a lot to do out there in science. And, and even if you're not a person who really thinks you're interested in science, there are plenty of other ways to be involved in space science. Like I mentioned, there's almost any kind of job has a role to play in space science. So if that's interesting to you, keep that in mind as you go forward, and you might find a path.
Very cool. One of my favorite parts of getting to these programs is I just get to see how many different types of science and scientists and people and interests there are out there. So even if you aren't a scientist, that you think there are so many ways for just you to pursue your passion. So this is really neat. I want to say thank you to a couple folks. Of course, to Vicki for your incredible storytelling and knowledge. It was great to get to learn about this stuff from you. Thank you, Kim. Thank you, Asa, who y'all can't see, but they're behind the scenes making all of this happen for this program today. I also want to thank our Telluride Middle School questions, as I know they're not even here right now. They had to leave for a fire drill. And thank you, everyone, of course, who put your questions in the chat. They were amazing. We could answer them all day. I know I have like 30 more questions in my head already. If you enjoyed today's program, I hope you come back for another one. On April 18th, next month, we will be going and talking about rocks in a different setting. In fact, we will be going to the south rim of the Grand Canyon. So you will have a chance to do a virtual field trip with us to the Grand Canyon and Scientists in Action, the grandest canyon and greatest mysteries. We hope you check out our former recordings and other Scientists in Action projects. We hope to see you at future ones. This has been so fun, and we will see you next time. So bye, everyone.